Hi all, this is the last video that we're going to have for this year, and it's just a review of our Chapter 2 concepts before taking the test on Tuesday. So let's first start off by going over reference angles. A reference angle is the angle made by the terminal side of an angle and the x-axis. I don't know why I said and the x-axis. So let's find the reference angle for these two angles for 247 degrees. So where would 247 degrees put us? Well, if I draw my quadrant and I draw a 247 degree angle, remember we always start on the positive x-axis. So 247 degrees is about here. 247 degrees. What we want to do is we want to find the angle made by the terminal side, which is this part of my, my angle, and the x-axis, which is this angle right here. All right, so how many degrees is that angle? Well, if I take 247 degrees and I subtract, what do I know? I know this amount right here, from 0 degrees over to the negative side of the x-axis, that's 180 degrees. So if I subtract that, I get 67 degrees, and that's my reference angle. So how does 67 degrees relate to 247? Well, for instance, if you want to find the sine of 247 degrees, it will create the same triangle but in quadrant 3. Okay, so in quadrant 3 sine is negative, so we could say this. Okay, how about if we wanted to find cosine? Cosine of 247 degrees, cosine in quadrant 3 is negative, so it would be the same as the cosine, the negative cosine of 67 degrees. How about if we wanted to find tangent? Tangent of 247 degrees equals the tangent of 67 degrees. Why? Because tangent's positive in both Q3 and in Q1. And just as a reminder, this is all students take calculus, okay, or ACTS, however you want to remember it. So how would you find the reference angle for a negative angle? Well, in a negative angle, we're just going clockwise instead of counterclockwise. And we know 1 full rotation is 360, 2 full rotations is 720. So how many more degrees would I have to go if I wanted to find negative 912? Well, if I go negative 912 plus 720, I get 192, or negative 192. So I need to go around 192 degrees more in a negative direction. So I'm about right here. So that's 912, negative 912 degrees. So I know up until from here all the way around twice, that's 720 degrees. That means from here to here is 192 degrees in the opposite direction, negative 720. All right, so I really want to know this angle right here. So I need to take off this amount of degrees, so that's 180. So what I'm going to do is I'm going to take that 192 degrees and I'm going to subtract 180 degrees from it, and I'm going to get 12 degrees. This right here is 12 degrees. So again, if I wanted to relate some of my trigonometric functions, I could say the sine of negative 912 degrees, that's a Q2 angle. So sine of negative 912 would be the same as the sine of 12 degrees. Cosine of negative 912 degrees, well, cosine in Q2 is negative, so it would be the same as negative cosine of 12 degrees. Tangent of negative 912 degrees, well, tangent in Q2 is negative, so it would have to be negative tangent of 12 degrees. All right, so now let's go ahead and practice using our calculator to find these trigonometric functions. And remember, when we use our calculator, most calculators don't have secant, cosecant, and cotangent. So how would we use our calculator to find it? Well, I'm going to make an equation out of this. All right, cosecant of 137 degrees 21 minutes equals some value x. So how could I change the cosecant? What's equivalent to cosecant? Well, I know that cosecant is the same as the reciprocal of sine of 137 degrees 21 minutes. Okay, so if I've got x already solved for, if I plug this in my calculator, I have it. So if I go 1 divided by the sine, what do I put in parentheses? I'm not sure if you remember how to convert minutes to degrees, but in parentheses, to get 137 degrees, I would get 137 degrees plus 21/60ths of a degree. And that's how I would enter it in my calculator. Okay, so I'm going to go ahead and do that in my calculator and see what I get. 137 plus 21 divided by 60. And I get that this equals 1.475975246. That's rounded to 6 decimal places. All right, so how would we do this if, let's make this a negative angle here. If I said, let's find the cotangent of negative 221 degrees and 37 minutes. Well, we don't have cotangent on our calculator, or at least most of us don't. So I would go ahead and set it equal to x and then find an equivalent function. So I know cotangent is the reciprocal of tangent. So I would set up my equation like this, and I would plug this side into my calculator. So I would say 1 divided by the tangent. Now, how would I plug this in? Because this is a negative angle, I need to actually calculate this first and then negate it. So I'm going to say negative, and in parentheses again, I'm going to do 241 plus 37/60ths. And I'm going to plug it in my calculator exactly like that, and I'm going to use those parentheses as well, because it is negative 241 degrees 37 minutes, all right? Not negative 241 degrees plus 37 minutes, okay? So this is the difference. You need to make sure that you add parentheses here and do this addition in parentheses and then apply the negative, okay? And this is important. This will be important for your test, so make sure that you know how to do this. All right, so how about if you wanted to find an angle? Using a calculator to find an angle in the interval of 0 degrees to 90 degrees, that's Q1, with quadrantal angles 0 or 90, that satisfies these conditions. Well, we know that we don't have secant. And I also know that in order to find an angle, I need to use the inverse function. So I need to convert secant to something we have on our calculator. So secant is the reciprocal of cosine. So we want the cosine of 1.1606249. All right, so how would I solve this? Well, I need secant in my numerator, so I'm going to multiply by cosine of theta on both sides. So I get 1 equals 1.1606249 cosine of theta. And then I'm going to divide both sides by 1.1606249. And so cosine of theta equals 1 divided by this number. So when I plug it in my calculator, in order to solve for the angle, I need to take the inverse cosine of this number, 1.1606249. So when I do that on my calculator, I get, let's see, I get 1 divided by 1.1606249. And I get theta equals approximately, I should write the approximate symbol, 30.5 degrees if I round that to 1 decimal place. So let's go ahead and do the same thing for this next example. We're going to find the cosecant of theta equals 1.3861147, and we want to find that angle. So I know cosecant is 1 over the sine of theta, and when I solve for sine of theta, I'm going to get sine of theta is the reciprocal of 1.3861147. So now I know that when I need the angle, I'm going to use my inverse function. And I'm going to set up an equation like this. All right, so now let's go ahead and plug that in your calculator. 1 divided by 1.3861147. And I get approximately 46.2 degrees. Okay, so the next examples that I'm going to do, I'm not actually going to solve them, I'm just going to set them up. We're going to solve a right triangle. And when you solve a right triangle, the way that you label your right triangle, C is always the right angle. Okay, so we label our angles as capital A, capital B, capital C, and the side across from an angle is its lowercase counterpart. All right, so it tells us that A is 28 degrees 34 minutes, and that little c is equal to 17.4 feet. So how would I solve for a missing angle B? So let's solve for B. Well, I know because this is a right angle, angles A and angle B are complementary. So how can I find angle B? Well, I'm going to subtract 28 degrees 34 minutes from 90 degrees, and I'm going to have to borrow a degree and change this to 89 degrees 60 minutes so that I can actually do my subtraction. Okay, so when I subtract, I get B equals 68 degrees 26 minutes. All right, so how am I going to go ahead and find little a and little b? Well, I'm going to tell you that I'm not going to use angle B because I calculated it, and if it was wrong, I don't want to propagate my errors. I'm only going to use the given information that I started with. So I'm going to find little b by saying, okay, little b is adjacent over hypotenuse, so that's going to be cosine. Cosine of 28 degrees 34 minutes is going to be little b over 17.4. And so when I solve for little b, I get 17.4 cosine of 28 degrees 34 minutes. All right, so remember when you enter that in your calculator, that will be cosine of 28 plus 34/60. Okay, and that's how you'll get your angle or your measure for side B. How about for side A? Well, side A is going to be opposite over hypotenuse. So side A is going to be sine of 28 degrees 34 minutes equals little a over 17.4. So little a is going to be 17.4 times the sine of 28 plus 34/60. Okay, we have time for one last triangle one, and then we're going to call it quits for this video. Here they give us only two sides. They give us little a and little c, 46.3. I'm going to label this A, B, and C. I'm going to say A equals 18.9, and this is little b. So I can use Pythagorean's theorem to solve for b. So b squared plus 18.9 squared is 46.3 squared. So b is going to be the square root, and it's going to be positive because we're talking about distances here, minus 18.9 squared. So you can plug that in your calculator and solve. So how would I find angle A? Well, I know I've got this side A that is opposite over hypotenuse. So that's the sine. Sine of A is 18.9 over 46.3. So A is going to be sine inverse of 18.9 over 46.3.